So I guess the main disruption in the antenna world is what the designer itself, in conjunction with TE connectivity, can conceive.
It's more what you can fit.
So it's Eamon here with ipXchange at the TE connectivity booth at Embedded World 2023, the second day. I'm here with John, and he's going to tell us a bit about antennas. So obviously a lot of devices use antennas, especially in IoT. Where would you say disruptive technology kind of exists in the antenna world these days?
Yeah, I mean, antenna physics don't change, have never changed. You can't break them, and the only way to get around or to be a disruptor is to bend them. So we have antennas ranging from 3 millimeters long, tiny little things that are embedded on a board, stuck to a board, soldered to a board, up to some of our largest antennas are 2 meters. Probably not great off a PCB. But one of the disruptors is not necessarily changing the technology, but bending it to fit the technology. So we have laser direct structuring antennas, otherwise known as LDS, which are the component here. This is a black plastic component that could sit inside any tablet, PC, laptop type device, and the congestion inside a device like that is quite heavy. So as well as PCB, you've got batteries, you've got screens, you've got power, you've got cables. They all cause interference and congestion and noise. So there are free spaces which are incredibly limited in a device like that. So a laptop, for example, you might have a strip down the side or a strip at the back where there is an empty space for a start, and a space that's far enough away from the battery, the screen, the power cables, to not be affected by those components. So what we do in this case is we can effectively laser print an antenna up and around and over a plastic surface, and that causes us to, rather than having a perfectly flat antenna like you would get from some of our FBC stick-on antennas at the back, the fact that we can print around, up and over the plastic surface means that we can give that a three-dimensional aspect, which means that we can get better performance, better patterns, higher gain, and effectively it's designed for that customer's product. So it's not off the shelf, it's a very in-depth process where we would go through that design with a customer. We would work on customer requirements, what frequencies they're trying to meet, what problems they're having at the moment, what limitations, and then we would work to come up with a designed-in solution. So our engineers and our team are very good at designing in for customers. So we don't sell them one antenna that 10,000 people have already got. We sell them a custom solution for that product. And the disruption is that the customer is not as forced to change their product to meet the needs of the antennas. And then in terms of the rest of the antenna world, there's only so much bending you can do. You want better performance, you have to get a bigger antenna. Or you either get a bigger antenna or a better antenna for better performance. But you need higher gain. Unfortunately, then you do start looking to go external antennas. They get bigger, all the way out to meter-long base station antennas, Yagi directional antennas. Those have ranges of kilometers, but unfortunately, physics does not shrink them down enough to be PCB mountable.
Cool. So I guess the main disruption in the antenna world is what the designer itself, in conjunction with TE connectivity, can conceive.
It's more what you can fit.
Yeah.
So IoT devices are getting smaller. We have more demand for frequencies. We have more demand for use of the one frequency, and we have more demand for number of frequencies or frequency technologies in a device. So where our device used to be Bluetooth back in the day, and your phone could talk to your fridge and get you a temperature rating, your fridge probably now has a location antenna, Wi-Fi antenna, can do Bluetooth. maybe it's a bit of a silly example for a fridge, but if you have a device that is on the move and needs to provide tracking information, it has to have GNSS, GPS in that device. If you want feedback to a mobile device like a phone or a tablet, you might need Wi-Fi. If it's out on the move and it needs connectivity, it's going to need cellular or 5G connectivity. So you need separate antennas quite often for all of those frequencies. And going back to LDS, that kind of is an advantage where you can put multiple antennas on that same strip and print them in place and not have that problem of integrating multiple antennas into the device.
Oh, nice. So, I mean, you obviously do a lot of work with antennas, your TE connectivity, so you're probably a good people to go to ask what kind of trends do you see in terms of the frequency bands that are being used these days in modern devices? Are you, obviously with IoT coming along, there's like NB-IoT, LoRa, like what kind of bands do you see being used?
Yeah, NB-IoT, LoRa, always going to be popular, low power, long range. Technologies for those have been around for a little while. The newer technologies or frequencies would be Wi-Fi 6E, which has only just come out. Wi-Fi 7 is now on the horizon. So that was a frequency extension, which is quite a rarity in the antenna world, but that gives a higher frequency to use for Wi-Fi applications, which means more users can be on the network at the same time, accessing that Wi-Fi network. They can be more traffic, there can be more throughput, so higher frequency gives you better throughput, more usability, more users. It doesn't travel as well through hard surfaces and walls. From outside building to inside building, for example, the higher frequencies don't work quite as well. So there's trade-offs on that, but more frequency is always good. In the cellular world, 5G. 5G we've talked about for years. It's been in our phones for 5 to 10 years. In terms of actual use in the outside world and in industry, it's not as highly used as people think. There's a lot of people still using 4G. Works very well. For lower data transmission, they don't necessarily need to change, but people who are now wanting to either stream, virtual reality, artificial intelligence, anything that takes a higher bandwidth, data throughput, 5G is now coming in for those technologies. So again, it's higher frequencies. We have more rollouts to come, which will take us up to 7 gigahertz in places.
Okay.
So we've got a serious expansion of maybe 3 to 4 gigahertz of usable frequency, which is almost double what we had previously.
How long do you reckon that kind of rollout will be in years-wise?
I mean, we're up to about 4 gigahertz. It's available now. Depends on your country. They all roll out in different phases. But I don't know, maybe 3 to 5 years we'll see that full 7 gigahertz spectrum. I think it's kind of demand led as well as bureaucracy led. So more people using it.
Get away from that bureaucracy.
Exactly.
Cool. So obviously TE connectivity to a lot of antenna-based solutions. What would be the best way for design engineers to kind of get their hands on, especially the kind of design consultation required to do the internal I can't remember what you called it. LBS type antennas.
Yeah. So LDS antennas do take a bit of back and forth. They need contact one of our product managers who will then bring in engineering support, and that's a bit more of an ongoing discussion. Our standard off-the-shelf antennas, they're available from our website. A lot of the products you can order a free sample.
Yeah.
So if you're designing your own setup and an off-the-shelf antenna is suitable, we have those ready to go. The LDS side, I would recommend getting in touch through our website. The relevant product manager will then start the discussion, tease out your requirements, and then bring in engineering support to find out what the actual product is required.
Yeah, because of course, like there's dream products and there's reality as well.
Exactly. Yeah. Physics. How great you're sending me.
Oh, yes. So that was a really lovely interview. Really thorough overview of what antennas do in this world at the moment. So I like to, at the end of every interview, ask, like, how are you finding the show? Obviously, it's Embedded World. It's one of the biggest.
It's been very good for us.
Yeah.
We do antennas, but we do a lot of other embedded hardware and components.
Okay.
So there's a real mix of customer interest here for us. Good days, long days, lots of customers, tiring, but definitely worthwhile being here.
Cool. Well, whereabouts are you based?
I'm based in Huddersfield, in the UK.
Nice.
Yeah, we're global though, so
Cool.
Wherever you live, there's probably one of us lurking around.
Nice. Cool. Great to chat to you, John. This is TE Connectivity. Look forward to talking more about your stuff. So that was a very interesting chat with TE Connectivity. Not necessarily disruptive, but if you're feeling disruptive, then they can help you design something that will make that a disruptive end product. We put an application form for the LDS antennas on the ipXchange website. So if you'd like to integrate that sort of technology into your product, remember they can be used for mechanical stability as well as electrical characteristics, then check out the links below.